everybody, welcome to section 3.82, transformations, day 2. We're going to capitalize on the hard work that you've been doing on transformations. And just to kind of recap what we did on day 1, the summary of everything that we kind of talked about, it can be summarized as this. You might want to write it down if you don't have it already handily, easily accessible. If you have to add or subtract in a transformation, that will result in a shift. If you multiply or divide, that'll be a dilation. If the transformation, if the number is outside of the parent function or outside of the parentheses, then it'll be vertical, and inside horizontal. So, for example, looking at this, because the 2 is outside of the function and being multiplied, then I can see it's a vertical dilation by a factor of 2. Just from looking at this and having all the top things memorized, then that helps me identify what kind of transformation it's going to be. So today what we're going to do is we're going to say, what if there's no formula? All of the functions yesterday had a parent function. You could see what the formula was either x squared or absolute value. But what if you don't have a formula? What if we're given a graph of the original and we know what the transformation is? How would we graph a new function? So let's take a look at this parent function here. It's a very strange parent function. Although it is a function, you can see it passes the vertical line test. You draw vertical lines, you can see every input has exactly one output. That's great. And then you can see we are even given these points that are plotted, like the function has values here, x values and y values here and here, but kind of at these really important turning points, they also give us these graphed, and we can read them off the graph if we need to. So if the input is -5, then the output is 0. If the input is 4, then the output would be 0, because that's what this point represents. 4 input, output 0. If the input is -2, then the output would be +2. And so forth. So that's how this function is defined. It's defined graphically, not by a formula, but that's okay. We can still transform it. So check this out. So g of x is, I just showed you a graph of f of x. That's the parent function. But what if we wanted to transform that to g of x defined by 2 times f of x? That would have to be a vertical dilation by a factor of 2, like we already talked about. Vertical because the 2 is outside, dilation because there's multiplication, and 2 is right there. So we would take this original right here, and tomorrow in class you're going to be given just a picture that looks like this, and what you have to do is you have to translate all of these numbers, and you have to transform all the numbers into new numbers that you would need and plot the points. My recommendation would be to make a table. Really great math students, when they're confronted with something difficult, they get organized, and that's the first thing we have to do. We have to organize all our information. Best way to do that here is a table. So you can see in black, I've already actually organized the information for you. These are the points that have been plotted for you in the original. All these black numbers right here are part of the parent function. Tomorrow, the textbook actually doesn't give that for you, so I would recommend you make a table yourself. You'll make the x, you'll make the y. You'll see, the first point is at -5, 0. Write it here. At -2, 2, 0, 0, 2, -4, 4, 0. The 5 different points translate into these 5 different rows. Now, if we're going to do a vertical dilation by factor of 2, that means we have to take all the y values and multiply them by 2. So I'm going to write my new y values here. 0, 2 times 2 is 4, 0, -4 times 2 is -8. You can see I get all my new y values. And then I have to plot them. I have to plot the point -5, 0, 2, -8, 4, 0. And when we do that, we see that visually we do see a vertical dilation by factor of 2. All the points have y values that have been multiplied by 2, and the distance between them and the x-axis, the horizontal x-axis, is twice as much as it used to be. If it's right on the x-axis, then you can see multiplying by 2 doesn't change anything. It does. The y value still is 0. All right, let's do the same process again with b. You can see here the 3 is outside of the function, and there's addition and subtraction, so I can see that because it's outside, vertical, plus shift 3 units here. It's going to be a vertical shift of 3. So I'm going to take all of the numbers that I see here, and it's the same picture over and over again in this case. So it's the same values here, and I'm going to show that I'm adding 3 to them all. You might say, Bergman, I don't really got to write the table. Come on, I can just add 3 to them. But I will say that given what's coming, given that these things are going to get more and more complex, you're not going to be able to add and multiply and divide all of them in your head. It's much better to keep track of them in a table now and get used to that habit of getting organized in a table so that when we increase the complexity, your table can accommodate and help you out in that way. So I've written, these are the original, the numbers in black, again, are from the parent function that's given, and the numbers in blue are the ones where I added 3, and now I can plot the points -5, 3, -2, 5, 0, 3. You can see here, when I plot all 5 of those new points, the whole function gets vertically shifted by 3 units. And visually, you can see it's higher up 3 units than the others. Moving right along, this is r of x is equal to f of 2x. This is going to be a little tricky, so take notes. If it's a little confusing, we can talk it out more tomorrow. But here we go. So 2x, remember our formula for the b value. If you want to look at an equation and figure out how much it's going to be horizontally dilated, you have to ask yourself x divided by what will give you that number. Like x, it's all about the x divided by something, and here we have multiplication. So the first thing we have to do really is change multiplication to division. So and the way that you do that is with the reciprocal. So 2 times x algebraically is actually the same thing as x divided by its reciprocal. The reciprocal of 2 is 1/2. The b value is 1/2. The amount that you're going to be horizontally dilating everything is by 1/2. The distance between all of these points in the parent and the y-axis, like if this is 4 units away from the y-axis in the parent, then in the transformed version, it's going to be half of them, which is going to be over here at 2. We basically have to cut all of the x values in half. We have to multiply all the x values by 1/2 or divide them by 2. So you can see here, it's the x values here started out as 4 and 2, and now the new x values are going to be 2 and 1. That's because we divided it by 2, or we multiplied it by 1/2. So here, the horizontal dilation is going to be by factor of 1/2, meaning they're all going to be half as far away from the y-axis as the original. Next, let's do example E. And here I see f of -1/2 x. All right, the -1/2 is inside. That indicates the transformation is going to be horizontal. It's separated by multiplication. That indicates that the transformation is going to be a dilation. And the question is really by how much? It's a horizontal dilation by a factor of something. And we won't really know until we change this multiplication into division, because the formula we have for the b value is x divided by b. So it's useless to try and tell you what you can multiply x times. It has to be x divided by, because that's what our formula says for the b. So I can change this multiplication to division just by taking the reciprocal. The reciprocal of -1/2, flip it upside down, is going to be -2/1, or just -2. So -1/2 x is the same thing as x divided by -2. That means we're going to have a horizontal dilation of -2. And horizontal dilation of +2 would be take all these x values and double them, make them more spread out, twice as far away from the y-axis. If you multiply it by a negative value, that's going to cause a flip. You're going to see that things get flipped around and then doubled as well when we multiply all the x values by that. So you have to ask yourself, what number times -1/2 gives you -5? That's +10. Maybe it's a bit easier to think about it in terms of like this. Like if you're going to take these values, 4 divided times -2 is -8. 2 times -4. 2 times -2 is -4. 0 stays the same, like this. So we can see here that if you want a horizontal dilation by a factor of -2, then you have to take all these values and multiply them by -2. The -1/2 is, if you want to know where this comes into the table, this right here is at the top, and this here is at the bottom. This is how we go from the parent to the transformed values. Multiply them by -2. All right, last up, multiple transformations in the same function. By the end of this, you'll be glad that you've been practicing using a table, because the table is really good for accommodating multiple transformations on the same function. Here's the original again. All right, I see a -3 on the inside. That's inside is horizontal. Plus or minus would be indicate shift. So this is going to be a horizontal shift of +3. Why not -3? It's because the formula is x minus a. And so what is the a value? It's +3. Formula already assumes subtraction. So x minus what? X minus 3. X minus +3 here. The vertical dilation I'm getting because I see a -2 times something on the outside. Outside the function would be vertical. Multiplication would indicate a dilation. And I see a -2, so this is going to be vertical dilation by a factor of -2. And then we add 1 here also because it's a vertical shift of +1. Vertical because it's outside the function, shift because it's addition, subtraction, and then 1. And so we're going to take the same graph and then the same starting table. You can see these are identical. But then we're going to transform. Maybe the y values would be easier to think about. We'll do this in PEMDAS order. So multiplication first, and then addition or subtraction next. First you multiply it by -2, and then you add 1. So here, for example, -4 times 2 times -2 is +8, and then +1 is +9. That's how you handle the y values. Here, you can see in order to get the new x values on the transform function, you have to add 3, like we talked about. It's going to be a horizontal shift of 3, so you're going to add you add 3 to all the x values, like this. If you want to know where the like you see x minus 3 occurring here, it's if you go in this direction. But if you need to find these new values, its direction is like this, +3. Wow, and then you can plot all these points. You plot these x values and these y values, and you can see we get a completely transformed, stretched, shifted, dilated function here. This has been horizontally shifted by +3, vertically dilated by -2. It's been flipped upside down, and it's been stretched by twice as much, and then it's also been vertically shifted. All right, that's a long enough video. Thanks for paying attention. Thanks for taking great notes, and I'll see you in class.